Okay, well, that was a great discussion there. I would like to have a lot of that for my end customers. I see it's being filmed, so maybe we can take this online and get it to my end customers, because that's what I'm dealing with a lot, is the end customers. And they're trying to figure out, okay, where's NVDIMM? How do I use it? And that's what I want to talk about a little bit about today. So if you've been around the industry for a while, which most of you here have, a lot of other customers haven't, there was a lot of infrastructure that needed to be put in place. Well, a lot of that's there today. We've talked about a lot more that's coming, and there is a lot more coming. That's great. So we're continuing this development, but there is a lot of infrastructure already there, and it's been a hard time getting there. It's been very, very difficult, but there's been a lot of work done, and I congratulate everybody that's participated in that in order to get NVDIMM and persistent memory to where it is today. But that's not the problems, that's the problems I've been dealing with for the past several years, but that's not what I'm dealing with today. Today I'm dealing with customers who say, yeah, okay, I understand the performance, I've seen the benchmarks, I don't know how I can use it in my system, in my application. Yeah, the benchmarks are good, but they're just benchmarks. Also, I understand that where block mode access is the best access and is going to give you the fastest performance that's available. But from what I understand, I've got to rewrite or have somebody rewrite this application, and I don't have the time, nor do I have maybe the expertise or even the cost and the budget to be able to do that. So, okay, I only have one option at this point. If I'm going to use it, it's going to have to be block mode because it's consistent with how my current applications are working. And yeah, it does give me better performance, and it gets me started. So yeah, I'd like to do that, and I've had customers saying that. But even then, it's like, okay, so what goes in the faster tier? What goes in the slower tier? How do I do that? How do I get this done? I don't know if I have the expertise or the time or even the budget to be able to do that. So that's what I want to talk about today, and what we need for this to move forward in a lot of customers is essentially tools that allows the customer to be able to, or somebody to come in and analyze the customer system with his certain application to evaluate his workload to figure out, okay, well, here's what's, based upon the accesses, this is what you should put in your hot tier, here's what you should put in your warm tier and your cold tier. And by doing that, you're going to get this type of performance. And based upon that, now, since you don't know how to really do this, let's have a tool that will automatically and dynamically put those data in those various tiers for you. So that's what I'm saying. I'm thinking right now we got to move to, and that's what I'm looking forward, is a really memory/storage advisory for customers, where you can go into a customer-specific system, analyze the workloads, and let them understand the performance and latency benefits before you actually change and put NVDIMM or an NVMe drive in this system, and then optimize that for him based upon his budget, his performance goals, and the capacities that he's going to need. The advantage of doing that is we're going to get a lot more input from the customers and their use cases and their workloads that we can then take back into our architecture development cycles to be able to bring out more products that can be more specific and hit the goals of these various workloads and applications. So to that end, I just set this up for Brashers to come in and talk about one such tool, kind of how we can go ahead and do this in the industry and what is needed and how we can accomplish that. So, Per?
Thank you. Feels like old home week. I've recognized like a good 30% of you all. It's great to be back. So really the question now is about if I can provide you a block mode interface, can you use it today? And the answer is yes. And so this ostensibly solves what Scott was talking about in the panel moments ago of I want to be able to have my active working data set close to my CPU, my inactive working data set close to my NIC, and my archival data set, all in the same namespace, but somewhere over on the other side of the data center where the guy costs me a lot less. Because the guy here next to the CPU, he costs a lot, right? So there's a lot of data management automation that happens in this. And really, that's all about being able to say, can you start working with it today? And the answer is yes, right? NVDIMMs are currently being deployed in some very niche locations, places where people actually know how to write things which use an mmap and be able to do that type of detail work. And now we're talking about, I give you a regular block-based interface and let you use any combination of material underneath it to hit the use case that you've got. Do you have Scott's use case of massively hierarchical? Do you have a use case of, I only want a database running on this thing, so everything is always hot? How hot is hot? Is it because I'm doing joins? Is it because I'm doing all kinds of other interesting work, right? So there's lots of questions about what is the temperature of data. And so really driving that adoption now is how we would do that. So what is this trick? Basically, the block driver in Linux and Windows is a little antiquated. Somebody was saying last century's 1970s solution, and that's exactly what we're dealing with, right? Some people even make the reference of, I took IBM punch cards and I put them on a spindle and they were in that spindle really fast and I still have the same damn format, right? That's pretty crude, unfortunately, right? So we have to be able to take and remap device accesses and say, this LBA is always the same LBA to the application. I will never, my hands never leave my wrists, even though this one tried once, right? I have to be able to do the remapping underneath that so that I can change this geometry. Meaning that if I say, hey, I need to be able to have some hot, or maybe even some LBA range that got cooler and moved down, and maybe even some that I would do different things to. And in this case, I'm showing off something like, hey, what if I just mirror to the NVDIMM? I never take a write to it, I just mirror to it. That's possible. What about, how about I stripe a bunch of them so I get really cool performance? That's completely plausible because I provide back to the OS the same exact address space. So now you've got one uniform access handle that doesn't change, even if you happen to come along and say, I'm going to rip this thing out because it's wearing out and put a new one in. So that's the type of quick, easy adoption that one can talk about. So rather than trying to say, take my word for it, look down in the regular stack. I mean, we've got a file system, or in the cases of some folks, databases, right? There is some filing system, if one may. There is some kind of logical volume manager because nothing ever works on a single LUN anymore, so we have to be able to deal with that. And then there is the standardized block translation layer. That's where we've inserted the driver, and that's where we go and do this virtualization layer. That means that now everything that could have been addressed before through that, whether that be a NVMe device, whether that be over fabric, whether that be localized, whether that be an NVDIMM, all of that is now provided back up to the block translation layer as a uniform and consistent address space. Then I move literally virtual LBAs around necessary to hit the workload. So Scott says, I want to have more than 8 seconds of working time for these guys who are drinking coffee and hanging out in the coffee shop. I say, great, you might want to have 10% NVDIMMs and the rest of this on NVMe devices. Zvonimir comes and says, you know what, most of my guys do all kinds of other things, and so I'm actually going to put only 1% NVDIMMs and a whole bunch of spinning disks because they really should be going to the coffee shop, right? So it just comes down to what is the workload. So that's the most important thing is you got to be able to grab the APIs. You got to get telemetry off of this, and you got to understand, I have a workload. Tomorrow, that workload is not going to be the same. So I got to be informed ahead of time. And then you start talking about, if I got the information, I've got the ability, I now have the ability to say, oh, wait a minute, I've got fabrics out there, so I could dynamically say, mirror this over to a faster tier and get rid of that, or get this off the fast tier and put it onto a slower, right? Now I have what the VMware guy was going on about as the virtualization causes all of this neat stuff to happen. I'm 100% behind him, except for the part where he keeps saying, it's coming in next year, it's coming in. What did IBM always say? It's in the next release? So, you know, here we are, it's in the release today, right? So let's take a look at just a quick demo that we had done over at Supercompute, and you sort of, I'm probably not going to be able to see from back there, but the numbers up here are in the 2 million range, and the numbers down here are in the 1 million, or just slightly under 1 million. And the 2 million range is actually made up of NVDIMMs plus an NVMe device, and the NVMe device is there just below the NVDIMM. And this is the standard workloads, synthetic workloads that everybody has to do because, quite frankly, we don't get enough actual customer data sets. So if any of you are customers, cut a data set, let us start using it. Like Facebook cut a data set for us, 5, 6 years ago. They've never cut a second data set, so we've only got the 1 terabyte data set. Give us like a petabyte, please, right? Make some data sets available. I say that in every conference I go to. So the NVMe SSD device, in this case, is my slow device. Right? We could even talk about, I could put a DRAM device in here and get higher numbers. I could do more striping up there and get higher numbers. Already I'm saturating the CPU complex, so at that point it's like there becomes a point of ridiculousness of what work am I leaving for the CPU to do? Right? Scott needs a bunch of CPU in his particular case. Zvonimir, do you need CPU in your case? Probably more than Scott does, right? So that's the real problem is workload analysis has to start with data telemetry. And then we fit the technology to fit the business case. So what is that telemetry, right? Today, if you were to look at a block device, it will tell you one set of stray aggregate numbers. I did so many IOs, they took this long, period. Boring, right? Here we got to go in and break down that LBA range and that block device into a much finer granularity and start realizing some portions of it behave differently. We've known for years, of course, the outer edge of the disk behaves differently than the inner edge of the disks. It's pretty obvious that an SSD device will behave differently than an HDD device. It's pretty obvious that we are going to run into interesting behaviors putting NVDIMMs in on top of an NVMe device. So we got to get more telemetry. That's number one. Break it up into more granularity, and then set in a whole bunch of parameters that are necessary to be able to actually answer the business question. Am I applying the right technology to this problem? They're all in real time. They all get logged. I personally tend to smooth out data a lot more than most people. I tend to smooth things out in sort of 30-minute increments because otherwise I get too much data. A lot of people like the 5-minute increment smoothing. It's a business decision, right? But then you get, I tend to write everything into a log host. So each of my clusters has its own unique log host. They all get to now see this cluster behaves differently from this cluster. Other people tend to say, no, you know what, I want this all to come into a single RESTful API, write it all into a single, and do the filtering later. That's a religious choice. That's not a technology choice, right? Now that you've been able to say, I know which pieces of my data are active, I know which clusters are behaving differently than other clusters, I can now go through and say, do I want to allocate more NVDIMM to this particular application or to this particular cluster? So it now becomes much more of a meta problem of how do I apply the right technology to that business problem that I just got given all this wonderful information for. So this is probably my least favorite graphic in the entire universe because what it represents is an LBA range from 0 to max, and it represents how much of those ranges are on which media. Now, if you followed that whole sentence, this is a great graph because that's exactly what it is. This LBA range here, there's a whole bunch of LBAs. These LBAs are on fast media, in this case NVDIMM, and these are on slow media, in this case NVMe device. So you can now look across the spatial analysis, and not only will you see I had a whole bunch of activity going here, but now I actually have a bunch of activity going here. Hey, it's about time to start moving some of these things onto the slow media and shifting that faster media in under here, because that's where my workload is actively. We do that automatically under the covers, so why should we even produce a GUI that shows you we're doing it automatically under the covers? There it is. So let's watch that animation. Each time you see a dark red line, you see something says, oh, I need to go steal it from you. Each one of these lighter blue lines that are about to show up here shows you, okay, I'm doing I/O in this region, but it has not yet been promoted. So in the case of Scott's examples, here we are, we're taking on a new scene, and it's going to span, in this case, about 60 gigabytes. And here you can see it says, I'm starting, okay, now I fill it up. So there is lag involved in this. What do you do with lag, right? Not everything is 100% on the same tier, on the same speed at any given time. So now you have a new business problem that didn't exist before, which is I used to know that everything I did responded at X speed. Now it responds at X speed plus X over Y plus X over Y plus, and so I now start talking about where in that hierarchy is my data. In the case of Scott, I'm saying I want a bunch of data here which I'm actively processing, and I want a bunch more data that I just have the ability to look at. Cool. But in the case of our Oracle guy, I can't take that kind of pain. So I'm going to put these two devices, I didn't realize it blacked out, these two devices as very close in latency to each other. So, you know, in the case of NVDIMM and NVMe, as opposed to NVDIMM and SATA SSD or something like that, right? So there's business choices to be made to meet that same workload. So if you go ahead and say, not everything is byte addressable and we are okay with addressing some things in the world of block, then you've got the ability to use this today, and you can say, I can create that multi-tiered IOPS, I can create that volume which behaves very much like the top tier volume, even though it is with multiple tiers across the whole system. I can go ahead and do that today. Ease of adoption means insert driver, remount file system, move on. Adoption of DIMMs, immediate, right? I can go out and I can get them from Micron, I can go get them from Peoples and set them up and say, here we go. And then you go combine all the analytics tools, you now start to get the view of what your application is doing, not what the sales guy told you your application was going to do. Thank you. You taking questions?
1 minute for questions.
1 minute. Or I start telling jokes.
You forgot to identify yourself.
I am Per Brashers. I used to work for lots of different people. I now work for myself. I tend to sit around on boards and tell people, hey, this is kind of cool, but maybe you should do things over here. I design a lot of software. I like to play, so yeah. Dan and I used to work together.